You ever stop to think about what's really going on when you click Save on a document? It feels so simple, right? Just one click. But behind the scenes, there's this incredibly elegant system that's organizing, storing, and protecting your data. So let's pull back the curtain and really get into the world of file handling.
Here's what we're going to cover. First, we'll look at the big split, text versus binary files. Then, we'll build a file from the ground up, from a single letter to a whole database. After that, we'll see how programs actually talk to files, and then check out some really smart ways to process all that data. And finally, we'll tie it all together to see why this is basically the foundation of our entire digital lives.
All right, so first things first. Not all files are the same. Broadly speaking, you can split them into two main camps, the ones that are meant for us humans to read, and the ones that are meant purely for the machine. So what's the real deal here? Why can you open a note on your computer and it makes perfect sense, but if you try to open up an application file, it just looks like a screen full of complete chaos?
And this right here shows you everything. Over on the left, that's an HTML file. It's just text. You and I, we can read it, we get what it's trying to do. It's human readable. But on the right, that's what happens when you try to open a program, an executable, in a text editor. To us, it's just total gibberish, but to the computer, oh, that is a perfectly structured, super precise set of instructions it can run immediately.
Okay, so now that we know the two basic flavors of files, let's peel back the layers and see how they're actually built. It's a pretty cool hierarchy, starting with the tiniest possible piece of info you can imagine. It all kicks off with a single character, a letter like A or a number like 7. You group a bunch of those together to make a field, which is just one piece of info, like someone's name. Then you bundle related fields, like a name, an ID, a salary, into a record. That's one person's complete info. A whole collection of those records, say for all your employees, that becomes a file. And when you have a bunch of related files all neatly organized, you've got yourself a database. It's just like building with Legos, starting with one tiny brick and ending up with a whole city. So we have these files sitting on our computers. How do our apps actually, talk to them? Well, it turns out there's this kind of universal toolkit, a set of basic commands that pretty much every single program uses.
It really just boils down to these 4 core moves. First, you gotta open the file. That's like telling the computer, hey, I need to use this thing. Once it's open, you can either read from it to get data out, or you can write to it to put new data in. And then, and this is super important, you have to close it. That's the step that actually saves your changes and tells the computer, okay, I'm done now.
And this is where it gets really cool. It honestly doesn't matter what programming language you're using. The specific words might be a little different, but these core ideas, open, read, write, and close, they are the true universal language for working with data. Let's see this in action. Here's a little bit of Python. Look how straightforward that is. You can almost read it like a plain English sentence. Open a file, write some stuff to it, and then close it. It's a perfect, clean example of those core concepts. Now let's switch over to Java. And at first glance, you might think, whoa, okay, there's a lot more going on here. And you're right, there's a little more setup. But if you look past that, the logic, the actual flow is exactly the same. You're opening something, writing to it, and then closing it. The what is identical, even if the how looks a bit more complex. And finally, just to really drive this point home, here's C++. The words are different again. You see things like oath stream, but the dance is the same. Open, operate, close. This is the big takeaway. No matter what language you're in, this fundamental pattern is how programs get work done with files.
All right, we've got the fundamentals down, but just reading and writing isn't where the real magic happens. The real power comes from being able to process that raw data in clever ways to get actually useful reports and insights.
So one of the most common and powerful tricks in the book is something called control break logic. All that really means is it's a smart way to go through a sorted file and do something like, say, print a subtotal at the exact moment the category you're looking at changes. Take a look at this. This is a classic example. We've got a list of sales, and it's all nicely sorted by region. But the question is, how do we get a total for just the North region before we even start looking at the South region? A simple brand total at the end just won't cut it. And this is where control break is just brilliant. The program reads that first line and thinks, okay, I'm working on the North region now. It keeps reading and adding up the sales for every single North record it sees. But the second it hits a line and sees the region has switched to South, that's the break. At that moment, it stops,
prints the total it calculated for North, resets its counter back to 0, and then starts adding up the new sales for the South region. It's such a simple idea, but it's incredibly effective for creating summary reports. Okay, another really smart technique is file merging. Let's say your company's East Division has a sorted list of employees, and the West Division has its own sorted list. Merging is just the process of combining those two lists into one big master list that is still perfectly sorted from top to bottom. And this shows you how it works. It's actually pretty elegant. The program basically just looks at the very first line from both files, it compares them, decides which one should come first alphabetically, grabs it and writes it to the new merged file. Then it just takes the next line from the file it just pulled from and does the comparison all over again. It's this little dance of compare and write, over and over, until you've built one big, perfectly sorted file. So we've covered the different types, how they're built, and some smart ways to work with them. But what's the so what? Why is this stuff so important? Well, because these ideas are the invisible foundation for pretty much all modern data management. In any big professional system, you're going to see this critical pattern, the separation of a master file from a transaction file. Think of the master file as your permanent source of truth, your complete inventory of every product you sell. The transaction file is more like a temporary notepad where you just jot down today's sales as they happen. And why bother with two files? Well, for one, it's way faster to write to a small temporary file. It also protects your huge, important master file from being constantly messed with, which lowers the risk of something going wrong. Then, at the end of the day, you can process all those changes at once, which is super efficient. And as a bonus, that transaction file gives you a perfect log of everything that changed. And finally, when it comes to actually getting at the data inside a file, there are really two main ways to go about it. Sequential access is like listening to an old cassette tape. You have to start at the beginning and fast forward to get to the song you want. It's perfect for jobs like payroll, where you have to process every single employee anyway. Random access is like a music streaming service. You can jump directly to any track you want instantly. This is absolutely essential for things like looking up a specific customer's account right away. And that really brings us full circle. From the moment you save your progress in a video game, to a bank processing millions of financial transactions a day, to just you typing up a simple document, all of it, every single bit of it, is built on these fundamental principles of opening, reading, writing, and organizing files that we've been talking about. The thing is, we are generating more data right now than at any other point in human history. Every click, every save, every post adds to the pile. So the real question becomes, as this data explosion continues, what does the next evolution of file handling even look like? How are we going to manage it all?